Next speaker, Sergey Miliaev from VisionLabs, the chief researchers. So the presentation is about face recognition today, recent advances and open challenges. Sergey.
Good evening to all of you. My name is Sergey Miliaev, and I'm head of the group that deals with face recognition at VisionLabs. And today I would like to talk to you about algorithms that we're working on and the tasks that we have. But I would like to start my presentation on a short overview of face recognition technologies in daily life. So the first thing that comes to our mind is face biometry that can be used by banks, for example, as an additional step in customer verification to provide customers with access to services, avoiding the possibility of some errors. And this face recognition is also important in some search systems that are searching people that have been lost. It is also can be used as a tool of access to documents and services of companies. For example, for airlines, it can give access to users to the air tickets or boarding passes to speed up this process. Or, for example, if you are a customer of a store, you can use this technology to get individual special offers without any need to provide some IDs or bonus cards or whatever else. Customer analysis is really critical to business today to understand the customers better and to improve the customized offer to them. And here, face recognition will also help to gather data in a more accurate manner and to assess individuals when they turn up in the flow of data from CCTVs of a store. Face recognition is today implemented in access control systems where it can replace the conventional cards or keys, access keys, to therefore enhance the convenience of using these devices, as well as safety. Payment services can also benefit a lot from face recognition technologies that will speed up user verification and also enhance the safety of the processes. As you know, not long ago, Moscow has unraveled the payment service in metro using face recognition. So now any person can pay for a metro trip with the help of his or her face, without showing any IDs or cards, if they beforehand registered their template in the system. After this brief overview, we can now focus on the tasks that face recognition algorithms solve in the systems. They can be broken down into two groups. First is face verification, and second is face identification. The task of face verification is as follows. We have two images showing faces, and we have to understand whether they belong to one person or don't. As an example, for example, we have Arnold Schwarzenegger and Terminator poster, and we want to understand whether these two images show one and the same person. The second task of face recognition is identification, as I have said. That is when we have some database of people and their images of faces, and we have a search query with the face image as well, and we want to understand whether this person from a query is in the database, and if he is there, who this face belongs to. An example of this application is when you like, for example, some shot from a movie and there are actors there, but you do not know them and you would like to learn what they are. And you have a database with pictures of well-known actors, and you can try to search for the face in this database using face recognition technology. Now we're getting at a very important moment, that is how to assess the accuracy of face recognition algorithms, and we will start with the verification task. Generally speaking, we can consider this task as binary classification task for every pair of pictures, and we have to say whether these photos, these images belong to one and the same person or to different people. The pairs where we have the same person are deemed positive pairs, and where there are different people, they are negative pairs. Therefore, we can introduce two key metrics present on this slide. The share of errors in recognition is the number of positive pairs to which our algorithm has said that there are different people, and that is the ratio to the general number of pairs showing one and the same person in our test. So the share of false negative identifications is when we look at the number of pairs of pictures with different people, and our algorithm believes that there is one and the same person. So we divide this number by the total number of negative pairs where different people are indicated, and therefore there are false match rates. Actually, every algorithm has a certain confidence level where it believes that in the input there is the same person, and this level of confidence can change the ratio between errors. If we have a look at the chart where positive pairs or genuine pairs are in green and negative or imposed pairs are in red, we will see that in case of maximal algorithm confidence for a positive pair on top, the difference between these two images is very little. But as soon as we move along the pairs where the confidence level goes down, we understand that the age changes, makeup changes, and the image is in more difficult conditions, then definitely we understand that it is similar to human face recognition. If we have a look at the negative pairs, we will see that similar faces generally can have not less value of similarity, and it also reflects our perception of these faces. If we can see relatives shown in the negative pair, it can also raise the confidence of the algorithm that it is a positive pair, and in case of twins identification, it is the most difficult both for the human being and for a computer. Usually we compare face recognition algorithms at a certain set fixed error of false match rate. And the best result belongs to that algorithm that at this false match rate gives the less false non-match rate. As for open results on the assessment of progress face recognition, I would like to have a look at NIST tests. They have face recognition vendor tests that are carried out really thoroughly, with a larger number of various input data, and apart from diversity of input data, the assessment of the algorithm accuracy goes along gender, age, race, This test also tries to follow modern challenges that turn up for the industry. For example, this year, they ran a separate test to assess the accuracy of recognition of faces wearing a mask. Why have I chosen this test? The industry is more and more actively taking part in this test. This plot shows the increase in the participation of companies in the recent years. It has almost reached 250, whereas the number of algorithms is almost 700. And for each algorithm, we can receive a detailed report on the indicators. And importantly, comparisons are shown not only related to other algorithms on some general tasks, but the indicators of a specific algorithm and its accuracy according to the certain testing attributes. Therefore, algorithm developers can see how vulnerable their algorithms are to certain input data to improve them, and potential users of face recognition can choose the algorithm that would suit their tasks. Some of these charts will be considered by us in detail in further slides. Let's start the progress of verification. So verification track progress with the visa database. That is one of the simplest images because they are done in controlled conditions in terms of face orientation and lighting. And the plot shows here the fall of error of the most accurate method, that is top 1 in green, and top 10. And we can see how error really cut and how much the difference in algorithm indicators went down. And if we have a look at more difficult face recognition, for example, based on mugshot database with less controlled face images, we will see analogous progress to the previous one. So the error has downscaled drastically, and the indicators of different vendors got closer to each other. Here, you can see the results of the test when we have images received from photo camera and video flow, for example, from web cameras installed at the gates in airports, and this is very frequently used in face recognition. And here we can also see that algorithms have increased their accuracy in a couple of years. VisionLabs has taken part in NIST test from the very beginning, almost from the very beginning, for 5 years. And from the very beginning, we have shown the leading results. Our algorithms have won several tests in these years, and our algorithms show the best results in speed and accuracy in our class of leading algorithms. Now let us have a look at face identification task. Here, you can see the results on identification accuracy on mugshot database with different sizes of the database. On the left-hand side, the number is 1.5 million, and we can see that at the very beginning of the test, the accuracy of algorithms of face identification was pretty good. And if we talk about dozens of millions, we will see that the results were not that high, but recently they have improved pretty much, which has expanded the sphere of possible applications of face recognition technologies, as we can witness now. This test also has complex queries for face identification with bad conditions like webcam face images or profile face images. And here we can also see pretty significant progress in recognition accuracy, despite the difficulty of these images. I would also like to point out a NIST test that it ran this year to assess the stability and sustainability in face recognitions with masks. And here we can see the assessment of errors for the best algorithm without masks, with masks, and we can see that the ratio of these errors can be several times, but if we see the error of the best algorithm today and several years ago without masks, that will show us good results. But generally, with masks, the error rate is not that high, so we can perform that task. Let us also quickly have a look at the main criteria, or I would put it differently, basis for algorithm progress of face recognition recently. First and foremost, that is the drastic growth of data volume. We can have a look at public papers from science, right, that will show that in 2014, the database size was about 500,000 for training, right? This year, databases were launched where the number of images is close to 50 million. And some companies from the industry also report that in training their algorithm, they can be databases with a volume of up to 500 million images. A very important progress in face recognition is also a research on the choice of optimal functions for training for these tasks. And it turned out that individual samples training, so to learn to place them correctly, should be or is better to be replaced with a task of classification with prototypes of people performing the tasks of classification on these prototypes. And sure, as it was pointed out in the previous presentations, architectures, face recognition architectures are a huge interest of scholars and scientists, and they have been researched really vastly recently. They have different speed and accuracy, and we have a pretty vast choice of models. This slide shows some joint statistics on publications on face recognition that shows the general interest in this task. Now, let us have a look at pending issues that we have in face recognition field. First is reliability to recognition in different subgroups, and here we can see the dependence of recognition error to some race or gender group. This chart, so here there are men only, and the error rate is different depending on the race and age. Therefore, we can make a conclusion that face recognition has certain issues with bias to race, gender, and age. The source of the issue is naturally the source of training data that are used for the training of face recognition algorithm. As it is based on deep learning, the largest potential is shown with the large number of training data. And generally, these data are taken from the internet. Some papers have analyzed the database, the training databases that we download, and there are certain issues in attribute distribution there, which is uneven, and therefore it influences uneven distribution of face recognition as a result. Another issue of face recognition is scaling this technology to other domain images. For example, we usually train face recognition algorithms on the images that can be taken from the internet, but usually they have to be launched for other types of images like near-infrared, and there are different technologies. And as there is difference in accuracy of images, the accuracy of recognition in the images can also go down. And the data collection for these domains can be problematic as well. This slide shows us the key takeaways on my presentation today. First of all, face recognition algorithms have shown drastic growth in accuracy in different scenarios, and it enabled to expand their application significantly in our daily life in various areas. And open testing of algorithms by NIST helped this progress, and developers have seen the issues that their algorithms have, and users have seen the most, the better algorithms to solve their tasks. And there are still open important questions about the fairness of face recognition algorithms and their applications expansions to the image domains like near-infrared, new type of input data. Thank you very much for your time and attention. Sergey, thank you very much.